Good afternoon, friends. In the last class, I left an exercise for you. And what was that? Remember, we are trying to look for what L by D I should select, or in fact L by D max I should select at the initial stage of the design, which should meet our design requirement. And in that, we have talked about range and endurance. And we left this exercise for you, and I hope you have done it. Question was, if this is the expression for range for a jet-driven airplane, to ensure I get maximum range, what should be the initial number for L by D? That is, at what L by D I should configure my airplane to be capable of. And to understand that, we will use the similar approach which we did for earlier cases. And you have seen the magic number of 0.866. When first time I read book, I was also wondering what is this number, right? So I thought, let us discuss. Now, if I will do some simple rearrangement, R is V. So V I can write 2 W by S rho CL under root, because we are talking about range and it's a cruise mission we are analyzing. So for range, I can write this equal to 2 W by S rho CL into, for L by D, I write CL by CD, and this is ln Wi minus 1 by Wi. To get a designer perspective, when I write I minus 1 means, suppose the cruise starts from here, ends here, I'm essentially looking for W1 by W2 or W2 by W1, so that I know, if I know W2 by W1, and if I know the value of W1, I know how much fuel is consumed in traversing from point 1 to point 2. Now see here, you could easily see the range proportional to CL to the power half by CD. So keeping everything constant, if I want to maximize range for a jet-driven airplane, it tells me I have to fly such that CL half by CD is maximum. You have seen for propeller-driven airplane and jet-driven airplane, for a range case, we had various conditions like CL by CD maximum, CL 3 by 2 by CD maximum. But here we are talking about jet-driven aircraft, and which we have done in performance course. It means CL half by CD should be maximum. Just to revise, what does that mean? You know, CD equal to CD naught plus KCL square. So I can write CD by CL half is equal to CD naught by CL half plus K CL to the power 3 by 2. Now you know, if I want to find out what is that CL for which CL half by CD is maximum, which is the condition here, indirectly I can tell, I can look for mathematically what is that CL at which CD by CL to the power half is the minimum, right? So we differentiate this with respect to CL both sides and equate it to 0, and you could check that second derivative, it will be positive, right? So this turning point, if I find out, I will get the condition CL equal to under root CD naught by 3K. So what is the message here? Message is, if you are having a jet airplane, if you are designing a jet airplane, and if you are looking for maximum range, you need to fly at an L by D. For that L by D, the CL should be CD naught by 3K. That is the message, okay? And if I understand that message, I write CL equal to under root CD naught by 3K. This is for jet R max by 3K, sorry. The message is, the moment I write CL is like this, then CD for best range, so I write best BR for best range will be CD naught plus K CL square, and which will be CD naught plus K into CL square means CD naught by 3K, and K goes, so this CD for best range will be equal to 4 by 3 CD naught. This is for jet driven airplane. This is important. But we also know CD for minimum drag. What was the condition for CD for minimum drag? It was CL by CD should be maximum, right? That was the condition for drag minimum, and that was equivalent to CD for minimum drag. The CL will be CD naught by K. This is known, well known to this, because it corresponds to CL by CD max. So I can now write CD for minimum drag will be CD naught plus KCL square. So this again will become CD naught. So this is 2 CD naught. So what is the observation? CD for best range will be 1.33 CD naught, whereas CD for minimum drag, we have seen here that CD for best range for a jet airplane is 4 by 3 CD naught, which is 1.33 CD naught. And we also know CD for minimum drag is 2 CD naught. So this I write 2, here I write CD naught, please correct it, 2 CD naught. So clearly you see that the CD for best range is less compared to CD for minimum drag. As a designer, sometimes it is misleading that you think, okay, best range means CD should be lower, right? Or CD should be higher if it is lower range. But if you think that CD for best range is 1.33 CD naught and CD for minimum drag as 2 CD naught, so the drag here will be lesser compared to this, that will be a blunder. Because what is drag? Drag has dynamic pressure. And dynamic pressure means that is where the designer has to be very, very disciplined. You cannot go for a telescopic conclusion, right? Every step as a designer you have to check. This is fine. CD for best range is greater than CD for minimum drag. CD for best range is less than CD for minimum drag. This is fine because you are seeing here CD for best range is 1.33 times CD naught and CD for minimum drag is twice CD naught. But if you think here, it means the total drag to achieve best range will also be less than total drag experience for minimum drag. That has to be checked. What is that? Why I am saying this? Please understand, whenever you are designing an airplane, the dynamic pressure plays an important role. Make it a habit of taking along with your dynamic pressure, because even lift, when I write lift equal to half rho V square SCL, I have seen most of us psychologically gets locked to what is the CL value? At the most, what is the wing area, right? But as a designer, you have to give due respect to dynamic pressure half rho V square, right? Because CL will be 0.2, but still you will be able to take 10,000 kg airplane in the air because of dynamic pressure primarily. And also why dynamic pressure I am telling? That this dynamic pressure will give you an idea how stronger your structure should be designed for, which your CL will not tell, right? So let us do an exercise here. If you see, V for best range will be what? We have seen CL for best range is under root CD naught by 3K, and we also know CL for minimum drag is under root CD naught by K. First of all, if you want to get feel for number, immediately you should understand that when I am flying at CD for best range, I am flying with higher speed compared to when I am flying with CL for minimum drag, because this CL is more than this CL, right? As a designer, this should immediately, that is how you develop feel for numbers. These things should automatically come to you, okay? The moment you know, oh yes, here I have to fly faster, immediately dynamic pressure will come to your mind. Faster means dynamic pressure more for a given altitude, so what will happen to the structure? All those things will come. So VVR for V for best range will be 2W by S rho CD naught by 3K, and V for minimum drag will be under root 2 W by S rho CD naught by K. Why these numbers are important, please also see from designer perspective. You may not allow your airplane, when you are designing, to fly at any speed. If this speed for best range is very high, right? You, at that point, you say, no, I cannot do that. So you start looking at W by S. If I reduce this, this man reduces, right? I try to look at CD naught, try to look at K. K means aspect ratio, right? You know, K has 1 by pi, roughly if I write. So these are the numbers where a designer will have a holistic view. He doesn't see only the speed. He sees, okay, if I reduce W by S, I can reduce it, because more of VVR, if I require, somebody has to give you power. You need an engine. It doesn't come out of free. So designer will not wait. Most of the book I have seen, they give you an algorithm, right? I do not appreciate such way of a design course exchange. Design means every number a designer should have a feel. For example, you can ask an aerodynamist, tell me what is the stall angle. He can do CFD, everything. He will be a better person to tell you what exactly is the stall angle for the aerofoil. He is good at that. But if you want to use that information, you as a designer should understand if the stall angle is 16 degree or 18 degree, how it is going to help or not, or may not help for when I merge everything together. That is why as a designer, every expression, every number you write, you should ask yourself, what does it mean? In terms of speed, in terms of dynamic pressure. That's why I give a lot of weightage to my way of understanding things. So this is clear now. So if I compare the drag for best range and drag for minimum drag, this will be half rho V square means 2 W by S rho under root CD naught by K. That will be V square, half V square S into CD naught is 1.33 CD naught, right? Divided by here is half rho 2W by S. Oh, this is not CD naught, this is CD naught by 3K, okay? Please note this correction. we know that the velocity for best range is 2w by s rho CD naught by 3k, and here it is rho under root CD naught by k into s into 2 CD naught. That we have seen. We have already shown that what is the effective CD for best range, which is 1.33 CD naught, and CD for minimum drag as 2 CD naught. Now, if I do the further simplification, I will find this to be as 1.154. So what is the interpretation? I hope you will be able to get this number. W by S, they cancel, CD naught cancels, 3 is there, K will cancel, rho will cancel. So you have 1.3, then 2 here, and then you will get this number 1.154. What is the designer's interpretation of this number? Please understand what we are looking for. We are looking for what should be the L by D, isn't it? We started all this thing because that Bragg equation for jet has L by D, and we are looking for how much should be the L by D. And we have seen if I am flying for best range using jet, then I have found out a ratio that the drag for best range will be around 15% more compared to drag experience during minimum drag flying. You see, in contrast to the CD interpretation. See here, CD, if you think from here, it tells you CD during best range is less than CD minimum drag. But actual drag, which is directly proportional to dynamic pressure, you see here that drag during best range is more than drag during minimum drag by 15% roughly. Okay? Which immediately tells you for a given CL, CL by CD minimum best range will be 1 by 1.154 CL by CD minimum drag. Obvious, because the drag is more, right? L by D, CL by CD. So now if you see this 1 by 1.54 is again this is 0.866 L by D or CL by CD max. So what is the message? So again this number 0.866 is coming. So the message is somehow you first guess what will be the L by D max you are designing for or aiming for. When you are trying to calculate what will be the range for the jet, you just take 86.6% of that L by D max. If you are planning for endurance, yesterday I have shown, you take 100% of L by D max. Like similarly for propeller driven airplane. Think you are at the era of Wright brothers, right? You don't have any airplane data, much of airplane data, and if somebody gives you a task, how do I visualize as a designer, what should be the L by D max? Right? Okay. How will you think? You will start thinking like a designer. Rest, what is happening today, you need analytics people. They'll get a database and they'll give you some number. But that is not the purpose of this course. Purpose is you should be able to think of an issue. As a designer, do you have experience of getting maximum number through minimum information? Right? Let us see, we are talking about L by D max or say L by D. What is L by D? L by D I can write as dynamic pressure in this into CL by CD. So this case, this is CL by CD. And what is CL by CD? CL is CD naught plus K CL square. Right? This is, I can write L by D, CL by CD, I can write as L by D also. Okay? What will be a typical value of CL you would like to fly? How do you get a feel for that number? As a designer, you are in the flight lab, okay? You have so many aircraft here. Their weight class is 1500 to 2000 kg, okay? So let us take some sort of a number. Let's say I'm trying to visualize through an airplane which is 2000 kg. And say S is around 10 meters square. So what is the wing loading here? What is the wing loading? 200 kg. And then let's say, for simplicity, I'm saying I am flying at an altitude where density of air is 1 kg per meter cube. Right? And I am flying at a speed, let's say, equal to 100 meter per second. Right? Purposefully, I have taken a speed at an altitude so that the flow is subsonic. Right? If I want to find out CL, CL will be what? That will be 2 into W, that is 2000, into 9.8. I am writing 10 for 9.8, divided by 2W by S, 10. The rho is 1, into V is 100 into 100. 2W by S, rho V square. Right? How much is this value? 0.4. The moment you get CL equal to 0.4, and if I want to see what will be the value of K, which is 1 by pi, aspect ratio E, and I take E equal to 1. So roughly how much is the K value? See, I am taking rough value because that is how a designer should work. Okay, to get a feel for number. This is 1 by pi, that is 3.14 into aspect ratio 10. Let's say I have taken aspect ratio 10. So K is how much? 1 by, it is 0.03 roughly. Right? The moment you are writing aspect ratio 10, more than 7 or 8, you are actually giving more weightage to the gliding performance. If you want to design a high-speed airplane, you try to come at around 7 for a transport airplane like that. No, 7 is okay. But if you are thinking of gliding performance, if you want induced drag to be less, then you need to go for high aspect ratio. The problem of high aspect ratio is structurally it becomes more demanding. The weight may go up, right? What will be the typical value of CD naught? You have done airplane performance course, and you have seen, you could see that CD naught typically 0.02, 0.021 to 5, like that. Even Dreamliner and all the latest aircraft, they have tried to make it less than 0.02, 0.018, and that is how they claim that the fuel efficiency has increased. They have reduced the weight, Dreamliner, by using composites, and they claim that its performance has enhanced, right? So these are the marginal thing goes on, okay? But as an initial number, CD naught 0.02 is not a bad number, right? So if CD naught is 0.02, then what I am getting, CL is equal to 0.4, and CD naught equal to 0.02. So CD equal to CD naught 0.02 plus KCL square, K is 0.03 into this is 0.4 square. So CD will be roughly equal to how much? Let me check. This is typically 0.0248. Okay. Now, if you want to see what is the CL by CD, that will be 0.4 divided by 0.0248, that is equal to, it will be around 16. So I could see that L by D is 16. What is the message? Message is, you take historic numbers, which are generic number, 0.02 order of magnitude, and all these are very historic numbers. And you find that L by D comes to around 16, right? So if I am a designer and I am ambitious designer, what I should do? I want to do, please understand, when you are making a product, 99% will be what have been done. Same sensors, same reliable sensors, material perhaps, but you have to add 1% new so that you can market it. So you have to add some ambition into your performance. So one of the most important ambition is, can you somehow reduce the fuel consumption? Nowadays it has come, can you make it green fuel, right? So if it is L by D, and I know L by D is aerodynamic efficiency, so I will be tempted to design for L by D maybe 17, 18, right? To start with little more, right? Because why? What I know as a designer, I know that already Dreamliner and latest aircraft, they have been successful in reducing this value 0.02 to 0.018. Already material development is happening where weight can further go down. So why not? I take the advantage of what is happening and I pick L by D 17 or 18. So this is my preparation. Now I should see historical data. That is what the difference I want to present. Don't just see some handouts and go on picking those numbers. That doesn't help. That's why many design courses happen, but few aircraft new design comes out. What is important, you prepare yourself so that pictorially whatever information is given, you are able to pick the right one. And that is the purpose of building this. In the next class, we will actually use some design charts. Okay, thank you very much.